This is passage 6. These are data slides. For data, we're going to use our DRC approach. Don't read, just do a quick skim, get the questions quickly. We know this is data because it only has figure 1, figure 2, so we're going to quickly glance and we see in the body O2 and CO2 are exchanged between lungs and tissue, so it looks like we have pressure of O2 in the atmosphere and the lung alveolar and lung capillaries. Looks like we're moving clockwise, left side of heart, right side of heart. And then we have alveolar ventilation. Don't even know what that is for sure. And pressure on the X and Y axis. And that's it. And I'm moving to the questions. For the questions, I want you to do a read then reread approach. You quickly read through the question and then you reread it, breaking it down step by step. We'll do the reread together. Number 35. According to figure 1, for a healthy resting person at sea level, as blood passes through the left side of the heart, make sure you're looking at the correct spot, which is greater, the pressure of O2 or pressure of CO2? And so we see that the pressure of O2 is 100, CO2 is 40, so O2 is greater, and it's at 100, so your answer is A. So number 36, we're doing the reread on this, remember. So based on figure 1, what is the range of the pressure of CO2 in the lung capillaries? We need to also understand that the arrows indicate the direction, so that it enters and then it exits, right? Leaves. So when it enters, the pressure is 40. We see that in choice G. When it leaves, the pressure is 46. We also see that in choice G. So range is difference between the highest and the lowest. So 40 to 46. So G. Number 37, based on figure 2, if a person's alveolar ventilation decreases from a value of 6.3, so we're going to the left, how does the person's O2 and CO2 respectively change? We have two columns, so let's look at the O2 line first, which we see right here, and as it moves to the left, it decreases, and then we have the CO2, which is here, and as that moves to the left, it increases. So your answer is C. Number 38, based on figure 1, does O2 in the air that enters the lung alveolus, so we're looking here, right? And so the air will be here, it enters here, so it's 104. Does that diffuse into the lung capillaries, which are here? So the lung capillaries is 100, so it's 104, and then it's 100. So diffusion does occur. So you have to know diffusion is like the spreading out of something, the moving through something. So the answer would be yes. And why? Because the lung alveola is greater than the lung capillary, so it does diffuse in. So your answer is F. Number 39. Consider the values of the pressure of O2 and CO2 that are given in figure 1 for the lung alveolus. So we're in a particular spot. We're also using figure 2, so we got to use both. To maintain the values, alveolar ventilation must be closest to which of the following. So let's break it down. So the O2 in the lung alveola in figure 1 is 104. So we're going to move that over to figure 2 now. And that puts it about that spot on O2, which looks like it's going to be about 4.2. Let's double check. CO2 is 40, which puts us close to the same spot. So it needs to maintain about a 4.2, right? That 4.2 is between both of them. So the answer has to be B. Number 40, just using this table below. So this table is all we're using. For how many of the combinations would CO2 diffuse from the tissue cells into the tissue capillaries? So the pressure on the right has to be less than the pressure on the left for there to be room for the diffusion to work. So how many of that has less pressure in the tissue capillaries? Only one. So your answer is F. A little bit of knowledge in that question. All right, reach out if you have any questions. We'll end on our silly joke. What do you call a lion whose car breaks down 5 miles from the zoo? A cab. Have a good day.